In today's analysis of mathematical thinking, we are going to be exploring the wondrous world of multiplication. To do this, we are going to analyze a few different strategies for solving multiplication problems, including partial products, the area model, lattice, doubling and halving, and of course, standard algorithm. We're also going to be looking at the content standards for the state of Colorado that align with certain math skills in multiplication. And we will be looking at multiplication through the one-handed tribe, also known as base 5, in order to get a better understanding of how our students will be looking at multiplication. So buckle up, have fun, and let's dive into multiplication. To begin, we are going to be looking at this problem, 432 times 38, through 3 different methods. So to start off, we are going to solve this problem using the left to right partial products method. On my virtual whiteboard, I have written down the factors, so it's going to be 432 times 38. So in order to do the partial products method, we are going to be breaking down each of these factors into their parts. So based on their place value. So I am going to start by breaking down this number here, 432, into its parts based on each place value in the number. So as we know, the 4 here represents 400. So I'm going to write 400 plus, then we know the 3 here is in the tens place, so that represents 30. And the 2 is just in the ones place, so it stands alone, 2. All right, so I have broken down this number here into 400 plus 30 plus 2. Now we're going to move to the 38 and break this one down based on its place value. So in the tens place, we have a 3, so we know that that means it's 30. And in the ones place, we have 8, so we are going to write 8. Now that we have broken down each of these numbers, each of these factors in the problem, we are going to use the distributive property to distribute and multiply each of these individual parts by each other. And in doing that, we are able to get the full answer by adding all of the parts together at the end. So I'll show you how to do that. So the first thing that I am going to do is I'm going to take my 30 here and multiply that by 400. So I'm going to do 30 times 400. And as we know, this just represents 3 tens times 4 100s. That's easy. As we know, 3 times 4 is 12. However, since it's 3 tens times 4 hundreds, we need to make sure that we have enough zeros. So from the hundreds place, we can see that there are 2 zeros. And in the tens place, we have another 0. So 30 times 400 is 12,000. Then we are going to move on to 30 times the next number in this problem, which is 30. So 30 times 30 equals 900. And we know this because 3 tens times 3 tens equals 900. All right, moving on, we have 30 times our last number in this top problem, 30 times 2. 30 times 2 All right, 3 tens times 2 equals 60. All right, so now that we have done the distributive property for this 30 and we have multiplied it by every single part of this number, we are going to move on to our 8 here. So now we're going to do the exact same thing. We're going to multiply the 8 by every single part of this number. So we'll start with 8. We're going to move left to right times 400. And we know that 8 times 4 equals 30, oh my God, 32. I had to think about that. But it's 4 100ths. So we're going to write our 32, and we want to make sure that we incorporate the hundreds. So we're going to take those 2 zeros and put them here. So it is 3,200. All right. So I'm going to scroll down a little bit. Then we're going to do our next number, 8 times 30 times 30. And we know that 8 times 3 is 24. But we're not doing 8 times 3. We're doing 8 times 30. So we need to make sure we incorporate that tens place by putting that 0 on. All right, so that's going to be 240. All right, we've done these two. Now we have their last one, our last way to distribute, which is 8 times 2. This one is easy because it is single digit. We don't have to think about the place values, making sure we latch on those zeros. So we just know 8 times 2 is what? 16. All right. So now that we have all of our numbers, we're just going to organize them by putting them underneath our problem so that we can see where the place values line up. And I'm going to do that real quick, and I will be right back. Okay, so I went off of camera to organize my numbers in order to make it a little bit easier to see. In hindsight, I would have just written the numbers right under this problem instead of doing it to the side. I would have done it at the same time, but regardless, we can still get to the same answer the same way. So as you can see, I put the 12,000 here because that was our largest number. The second largest number was 3,200, and I put that right underneath. And then our third largest number was 900. I put that right underneath that one. Next up was 240, which I got from right here, and 60, which I got from here. And last but not least, 16, our smallest number, came from this right here. So I drew little lines so you can see where each of these numbers came from in order to make it a little bit easier to understand. So now that we have all of the, we've done the distributive property, we have all of these numbers ready to go. All we need to do to get our final product is add them together. So I am going to get a new color. How about light pink? And we are going to add them together to get our final answer. So over here, we just have 0, 0, 0, 0, 0 plus 6 equals 6. 0, 0, 0 plus 4 plus 6 plus 1. We know 6 plus 4 is 10. Then plus 1, which is going to be 11. So we're going to write the 1 here. Carry that 10, redistribute over here, or I guess it's going to be 100, but carry that digit over here. Then we have 1 plus 2, which is 3, plus 9, which is going to be 12, plus 2 more, 14. So again, we're going to write the 4 here, which is the ones digit from that answer. Then we're going to redistribute that digit over here, the 1. Then we are going to add 1 plus 2, which is 3, plus 3, which is 6. And then last but not least, we have in this 10,000s digit, we have just a 1. So that leaves our final answer to be 16,416. All right, so we are going to use a few more methods and we're going to find out if this answer is the answer we want. Next up on our list is the area model. We are going to look at the same problem, just using a different method. All right, so for the area model, I've already written out the problem over here, which is 432 times 38, and I've drawn out our box. So what we do in the area model is a very similar thing that we do in the partial products method. However, we are just going to be writing it a different way. So to start off, we are going to, up here, I am going to write 432, but I'm going to break it apart into its parts. So first we have 400. Then we have, in our tens place, whoa! In our tens place, we have 30. And in our ones place, we have 2. All right, we're going to do the same for 38. So in our tens place, we have 30, and we're going to be writing it over here because then we are able to draw our box and visualize what we're doing. So 30, and then in our ones place, we have 8. All righty. So in here, we are going to draw out squares so that each individual digit in each place value can be multiplied by each other and distributed. So we're doing the distributive property just visually. So there we go. So each digit has its own box. So I'm going to start off right up here with 30, and then we're going to multiply that by 400. And I'm going to write my answers in green. So 30 times 400 is going to be 12,000. All right, and we know this because we do 3 times 4 in these digits here, which is going to be 12, and then we want to make sure that we factor in the fact that this is represents 3 tens. So we're going to represent that with a 0, and then this represents 4 hundreds. So we're going to represent that with 2 zeros. So we got 12,000 here. Then we're going to do 8 times 400, which is going to be 3,200. Same thought process here. So we're doing 8 times 4, which we know is 32. Then we're factoring in, it's not 8 times 4, it's 8 times 4 hundredths, or 4 100ths. So then we want to make sure that we include where the hundreds go in with the zeros here. So we just include those on the number to make sure that it's the correct place value. All right, oh, and I want to make sure I include my comma. Then we're moving on to 8 times 30. So 8 times 3 is going to be 24. And since it's 8 times 3 tens, we want to make sure we add, or we don't add the 0, but we include the 0 in our answer here. All right, then, oh, I wrote that in the wrong place. I wanted to make sure that I write the 8 times 30 not in this square because that doesn't align with the 8. We want to make sure it aligns with both of the numbers. So as we figured out, it's going to be, oops, that's fine, 240. All right, then we do 30 times 30, which is going to be 900, because 3 times 3 is 9. Then it's 3 tens times 3 tens, so we want to make sure we include the zeros there from those tens. Then 8 times 2, that's easy. We know that is 16. We don't have to worry about the other place values, all the hubbub. We just do it the way that we always do. 2 times 30. 2 times 3 is 6. And then we want to make sure we factor in that 0, which is 60. Now that we have all of the numbers here, all we need to do is add them all together. So in order to do that, I'm just going to zoom out here, make a little bit of space. There's a couple methods you can do it as long as all of them are accounted for. That's all that matters. So what I like to do is I like to do the bigger numbers first. So I'm going to do 12,000 plus 30, or 12,000 plus 3,200, which is going to be 1,520. Oh, what? Or I'm sorry, 15,200. Then I'm going to do these two numbers together, which is 900 plus 240. So we know that 0 plus 0 is 0. 0 plus 4 is 4. And 9 plus 2 is going to be 11. So we're going to write 11 in the hundreds place, 4 in the tens place, and 0 in the ones place to give us the answer of 1,140. Then, moving on over here, we have 60 plus 16. 0 plus 6, is 6. And 6 plus 1 is 7, so we have 76. All right, so we have added some of these numbers together. Now we just need to add these numbers together that we have in order to get the final product of 432 times 38. So I'm going to write these up here. So it's going to be 15,200, which we got from adding these two together. Then we have 1,000. Make sure we line up the place values. 1,140, and which we got from adding these two, and we have 76, which we got from adding these two, which I already drew a lovely line for. So 76, all lined up, ready to go. 0 plus 0 equals 0, plus 6 equals 6. 0 plus 4 is 4. Plus 7, so we just know 4 plus 7 is 11. So I have the 1 down here. Carry the digit up here, redistribute, and we have 1 plus 2 is 3, plus 1 is 4. Moving on over, 5 plus 1, which we know is 6, and this little guy standing alone, 1 plus 0 is 1. So we have our final answer of 16,416. Let's see if that's what we got over here. That is what we got over here. The reason I check is to make sure that I did all of the addition and multiplication correctly. All right, that was the area model, and we are moving on to our next method. Next up on our list is the lattice method. All right, for the lattice method, we are going to begin by drawing a box, similar to how we'll start the area model method, but a little bit different in the way that we execute it. So here is our box, and on the top, we are going to write our first number, which is 432. And then on this side, instead of this side, we are going to write our next factor, which is 38. Now we want to draw individual boxes for each of the place values. So instead of writing out what each place value represents, like in the area model, we just know. And so for students, we'll need to have a pretty good knowledge of place value awareness and what each number represents before learning this method. So I drew the box and boxes for each of the place values so that we can do the distributed property. And now I'm going to draw my lines to divide up these boxes and make space for the multiplication. So we're doing digit by digit. So the first thing I'm going to do 8 times 2, which is 16. 3 times 2, which is going to be 6. So there I'm going to do a 0 here and 6 down here. Hope you can tell that's a 6. 8 times 3 is 24, so I'm going to write the 2 up here, the 4 down here. 3 times 3 is 9, 0 in the tens, 9 in the ones. 3 times 4 is going to be 12. And 8 times 4 is going to be 32. So now that we have multiplied each digit and distributed each digit, we are going to add these together. Now, we drew these lines so that they can represent the place value. So when we're adding them up, we're going to keep in mind that the place values are going to be written out for us. So we don't need to think about the zeros and how many 100s this represents until the very end. And so that's something that I want to keep in mind when I'm teaching this method, because when I learned this method, I didn't really have a good full grasp of place value, so I didn't understand what exactly I was doing. So that was me going on and on. All right, so what I'm going to do is I'm going to add each digit together, each value together. So in this, under this line, we have 6. Then I'm going to add 6, 1, and 4. 6 plus 4 is 10, then plus 1 is 11. So I'm going to do the 1 here, carry that digit up here and redistribute. So I'm going to do 1 plus 9 is 10, plus 2 is 12, plus another 2 is 14. Write the 4 down here, redistribute the 1 into the next place value over. 1 plus 2 equals 3, plus 3 is 6. And all alone up here we have 1. So now that we have it all written out, we are going to write down the whole entire number as one number. So we have, in the thousands place, we have 1. In the thousands place, we have 6. In the hundreds place, we have 4. In the tens place, we have 1. And in the ones place, we have 6, which leaves us with an answer of 16,416. And we know that's correct because that's what we got for the last few answers. All right, now that we have used 3 different methods to solve 432 times 38, we are going to move on to the next problem. We are going to solve 387 times 64 using standard algorithm. Right, so to begin in standard algorithm, we first need to start off by stacking our numbers on top of each other. So I always do the larger number on top, which just makes it easier to do the multiplication. And we want to make sure that the numbers are aligned by place value. The ones are aligned with the ones digit, the tens are aligned with the tens digit, and the hundreds are aligned with the other hundreds digit. Now, the 3 in this 387 stands alone because there's no hundreds place here, but we're going to imagine that there is a 0 here to show that it is aligned. So anyway, what we're going to do to start off is we are going to imagine that we're doing, we are first going to do 4 times 387. We're starting with the ones place. So to start off, we're going to do 4 times 7, which is 28. So we're going to write the 8. We are going to write the 8 down here. And plus 2, we're redistributing the 2 up here. Then 4 times 8 is 32, but we're going to add that 2 back in. So 32 plus 2 is 34. So we're going to write the 4 down here from that 34 and redistribute the 3 over the next digit. So now we have 4 times 3, which is 12, and then we're going to add 3 more, which is 15. We want to make sure that they're still aligned. So for 4 times 387, we got 1,548, but we are not done yet. So we now need to multiply the tens place by 387, which is the 60. So since we know that this 6 here represents 6 tens, we want to make sure that we consider that in our answer. So we are going to be writing a 0 here to demonstrate that we're not going to have any ones since we already just multiplied our ones place. So that 0 here is considering that this is 60, and now we can continue our multiplication. So I'm going to erase where we redistributed here so that we don't get confused. Or you know what, since we're writing in a different color, we are just going to pay attention to the purple so that I don't erase any of the work that I have. So we have 6 times 7, which is going to be 42. So we're going to write the 2 down here from the 42, and we're going to redistribute the 4 up here. So now we're paying attention to the purple, remember? So 6 times 8 is going to be 48. So, but then we need to add this 4 back in. So 48 plus 4, 48, 49, 50, 51, 52. So we're going to write the 2 down here, the next digit over, and put plus 4. Oh, I'm sorry, plus 5, because we had 52. Did I say that? I may have said the wrong thing. Yeah, 6 times 8 plus 4 is 52. So we redistributed the 5 over the next digit over. So now we're going to have 6 times 3, which is going to be, wow, why am I struggling with that? 18. And then 18 plus 5 is going to be 18, 19, 20, 21, 22, 23. So then we'll write 23 down here. I realize I never wrote my comma here on my first answer. So now that I have done that, we have multiplied the 4 from the ones digit by 387 and the 6 by 387. So we have these two numbers here. So all we need to do to get our final product is add them together. So 8 plus 0 is 8. 4 plus 2 is 6. 5 plus 2 is 7. 1 plus 3 is 4. And 0 plus 2 is 2. So our final answer, the product of 387 times 64 is 24,768. All right, so now we are going to be moving on to find the grade level and evidence outcomes for each of the following mathematical skills using the Colorado Academic Standards. So the skills that we are looking for are the standard algorithm for multiplication, algorithms based on place value, such as partial products, and multiplication fact recall. So to start off, we have standard algorithm for multiplication. This, the evidence outcome of this skill is that students should be able to fluently multiply multi-digit whole numbers using the standard algorithm by 5th grade. Here is what the standards, code is 5, number base 10, and this is B. All right, and then next is algorithms based on place value. The evidence outcome is that students should be able to multiply a whole number of 2 to 4 digits by a 1-digit whole number and multiply 2-digit numbers using strategies based on place value. And the properties of operations illustrate and explain the calculation by using equations, rectangular arrays, and or area models. And students should be able to do this by 4th grade, and here is the standard here. Now for the next one, we have multiplication fact recall, and this was a trick question, unless I'm completely missing it, but there is no standard that I could find anywhere where students are expected to be able to recall multiplication facts. For the final question of the AMT, I will be using the one-handed tribe, they're coming to visit, also known as base 5, to multiply 132 times 2, 4. So the methods that I will be using are the area model and partial products. And to answer the second part of this problem, how did I determine the base 5 facts? And I did use a base 5 multiplication chart that I made to help me visualize and get my facts organized. Alrighty, so to start off with the area model, I already drew it out since I already demonstrated how it's drawn out and what we do to determine what goes where. So I put put 1, 0, 0, 3, 0, and 2 from 1, 3, 2 up here, 2, 0, and 4 on this side here, and now it's time to start multiplying. So I have my handy dandy base 5 multiplication chart here to help me with my facts. So I'll be going back and forth. So I'm going to start off with 1, 0, 0 times 2, 0, which is 2, 0, 0, 0. And I know this because when I look at my multiplication chart, so do I put another 0 on it? Maybe I should have made this chart bigger. Well, let's see. So if I have 2, 0 here and 1, 0 here, and then it makes 2, 0, 0. Oh, no. That's right. So, okay, cool. So, yes, I believe that this is correct, that 2, 0 times 1, 0, 0 is 2, 0, 0, 0. All right, moving on to 2, 0 times 3, 0, which is going to be, if I look at my handy dandy multiplication chart, we're going to look at 2, 0 times 3, which is 1, 1, 0. And then since I since these are both in the 1, 0 place, I'm going to make sure that I consider that extra 0. So instead of it being 1, 1, 0, the answer to this is going to be 1, 1, 0, 0, because I am taking into consideration that they are both in the 1, 0's place. All right, so 2, 0 times 2, if I look back here at my chart, we can see 2, 0 times 2, I'm going to go all the way down, equals 4, 0. So I am going to put that right here. So the multiplication is similar here in these digits as it would be in base 10, I'm noticing, especially for the 2, 0 times 2, since the answer is still less than 5, or 5, 0, I guess. Anyway, just something I'm noticing. All right, so 4 times 1, 0, 0 is going to be 4, 0, 0. And 4 times 3, 0. I'm going to look at my chart again. So I look at 4 and 3. 4 times 3 is going to be 2, 2. So 4 times 3, 0 is going to be 2, 2, 0, because I'm considering that this represents 3 1-0s. And then 4 times 2 in base 5, I'm going to look at my 4 here on the chart, times 2 is going to be 1, 3. And now all I need to do is add these together. So what I'm going to do is I'm going to start here and I'm going to go 2, 0, 0 plus 4, 0, 0 is going to be 2, 4, 0, 0 plus 1, 1, 0, 0 plus 2, 2, 0. So we have, we're going to have 0 in the 1's place, 2 in the 1-0's place, 3 in the 1-0-0's place, and 1 in the 1-0-0-0's place. So 1, 3, 2, 0. And then over here we have 0 plus 3, which is 3, and 4 plus 1, which is going to be 1, 0. All right, we add these together. So I'm going to write it out up here. I'm not going to use that color. I'm going to use a different color so you can see what I'm doing. So I have 2, 4, 0, 0 plus 1, 3, 2, 0. That's a funky 3. Plus 1, 0, 3. All right. Whoa. I am losing it here. Base 5 gets me feeling all kinds of whack. All right. So we have 0 plus 3 is 3. 0 plus 2 plus 0 is 2. 3 plus 1 is 4. 4 plus 4 is a little bit trickier. So I am going to count on my fingers back here. So if I have 4, actually let me try to demonstrate it here. So I have 4 plus 4. These are like just little lines, my counters. So if I have 4 and then I have 1 here, I need to redistribute when I have 5 altogether into, that's representing 1, 0, and then 3 left over. So this is my 1, 0, and then I have 3 left over. So that would be 1, 3. 4 plus 4 in base 10 is 1, 3. So I'm going to write the 3 down here, put the 1 up here. 1 plus 2 is 3, plus 1 is 4. So our grand total is going to be 4, 3, 2, 3. Righty, last but not least, we are going to be doing partial products for base 5. So if we remember from earlier, when we do partial products, we are breaking apart each number by their place value. So similar to how we do it in the area model, but just less visual and more with just the numbers. So for this, we're going to break it apart by 1, 0, 0 plus over here in the 1-0's place, we have 3, 0. And in the 1's place, we have 2. Then right down here in this number, we have in the 2-0's place, or in the 1-0's place, we have 2, 0. Plus in the 1's place, we have 4. All right, so now that we have broken apart our numbers, it is time for us to redistribute. So what we are going to do is we're going to multiply each number, each part of the number down here, each digit, by each other digit, if that makes sense. We're using the distributive property to distribute each of these. So first I'm going to do 4 times 100, which is going to be 400. So I am going to write that. Now, last time I had a hard time figuring out how to best organize it, but I think I'm going to do it the same way because it helps me keep it organized here. So 4 times 100 equals 400. Okay, so I've done that. Now I need to do 4 times 30, which is going to be, I'm going to have to look at my base 5 chart again. So we know that 4 times 3 in base 5 is 2, but it's 4 times 3 zeros, so we need to make sure we keep into consideration that this is representing 3 1-0s. So instead of 2, it's going to be 2, 2, 0 to make sure it's in the right place. All right, and then we need to do 4 times 2. And in base 5, I believe that's 110. Let me just make sure. 4 times 2, no, it's 13. Oh no, wait a minute. 4 times 2, yeah, 13. Still learning my facts. So now I'm going to write these underneath the answer just so I can, or right underneath the problem, so I can keep track of all of it. So we have, from doing the distributive property from just the ones place, we have 400, 220, and 13. Now I am going to do the distributive property for, or partial products, for the 10's place, which is 20. So I'm going to be multiplying 20 by each of these digits or parts of this number. So I'm doing that in blue, and I'm going to do it over here. So I have 2, or I'm sorry, that's not blue. That is yellow. 20 times 100. Go scroll over a little bit. Is going to be 2, 0, 0, 0. Because we want to make sure that we're considering exactly where it is in its place value. Then I'm going to do 20 times 30. And then if we refer back to our handy dandy chart, 2 times 3 is 1. So we have 1, but then we're not doing 2 times 3, we're doing 20 times 30. So in order to make it sure it is in the right place, we want to tack those zeros onto the end of it so that it takes care of those digits. All right, then we do 20 times 2. And referring back to our chart, we have 20 times 2 is going to be 40. All right, now we're going to put those also underneath our original problem. So we have 2, 0, 0, 0, 1, 1, 0, 0, and 4, 0. All right. It's not perfectly organized under there, but we can see that everything is lined up by their place value. So when we add it up, we are going to be able to get to the answer, hopefully, that we want. That is mathematically correct. So we're going to add this all up and get our product. So as we know, 0 plus 0 plus 3 plus 0 plus 0 plus 0 is 3. 2 plus 1 is 3, plus 4 is going to be 1, 2. I'm just going to check that. 4, oh wait, that's multiplication. So let me check it with my brain. 4, 1, 0, 2, 0. 1, 0, 1, 1, 1, 2. Oh, it's going to be 1, 2. Hold up. Yeah, it's 1, 2. Okay. So I'm going to put the 2 down here. I'm going to carry and redistribute up into the next digit over. So 1 plus 4 is going to be 1, 0. Plus 2 is 1, 2. Plus 1 is 1, 3. So I'm going to put the 3 down here, redistribute that 1 up here. 1 plus 2 is going to be 3, plus 1 is 4. So the grand total for 132 times 24 is 4323. Is that what I got last time? It is what I got last time. Ah, isn't that beautiful? So the final answer, hopefully, is 132 times 24 equals 4323. Watching my AMT on multiplication. If you made it through this video without falling asleep, I commend you. I know that this was a very long video, but I wanted to make sure that I included all the details that I could, and I reiterated the points that I kind of missed when I was learning multiplication the first time. So I hope that I was able to demonstrate my thinking, and let me know if there are any revisions that I need to do.